In this lecture, I'll dive into the steel crossbeam design. And do note that some details do use timber crossbeams, but we primarily use the steel crossbeams in country, so we'll be discussing that in this lecture. And associated with the W3 detail is the C1 and C5E crossbeam details. These are the two channel crossbeam types that we can procure in either Bolivia and Eswatini. And then note that A in parentheses refers to if a center cable guide is necessary or not. So you'll see something that looks like this in the detail for the center cable guide. Those details are the same other than the center cable guide being applied. Now, like mentioned above, the Bolivia detail, C1, uses the C4 by 5.4 crossbeam detail. This stands for channel, the C stands for channel, and we can use the AISC Steel Construction Manual to look up information for this detail type. Table 1-5, or C shapes dimensions here, has a row for C4 by 5.4, along with an easy graphic at the top of the table to show which dimensions we are using. We can read an area of 1.58 square inches with a nominal weight of 5.4 pounds per foot. And we can take the SY and ZY values because we are bending about the weak axis. So we read SY is 0.277 and ZY is 0.565 from the second page of the table. The C5E detail specifies as a C100 by 50 crossbeam, which is the C4 by 7.25 equivalent using table 17-3 for SI equivalents of standard US shape profiles. This tells us the crossbeam has the same shape, but is a bit heavier than the detail used in Bolivia, because it has that 4, the 7.25 is its weight per linear foot. So we can go back to table 1-5 and get our area, our SY and Z values. Now that we have the channel dimensions, we turn all the way down to AISC 360 specifications, Chapter F, for the design of members for flexure to perform our flexural analysis. Using our engineering judgment here, we will only check for flexure because this is generally what governs steel design, and we can tell by the loading and shear stress. We can tell by the loading that the shear stress will likely not govern. So into the next lecture, I'll dive into Chapter F and how we'll actually check for flexural capacity of our steel channel.